November 8, 1942. 0847 hours. Outside Casablanca, Morocco. Oberst Friedrich Weber watched through his binoculars as American M4 Sherman tanks rolled toward his position at what seemed like suicidal speed across the uneven coastal terrain. His Panzer IV crews had already ranged the approach routes, confident that no tank could fire accurately while moving at such velocity over broken ground. What happened in the next 90 seconds would shatter everything the Wehrmacht thought they knew about armored warfare. The lead Sherman, traveling at nearly 15 miles per hour across rutted farmland, fired its 75mm gun without slowing. The round struck Weber's command halftrack 300 meters away, killing his radio operator instantly. Before German gunners could respond, two more Shermans fired on the move, both rounds finding targets. The German tankers were witnessing something they had been told was impossible: accurate fire from a moving tank platform. They didn't know that the Americans had secretly equipped their Shermans with a weapon system the Germans wouldn't perfect for another 2 years, a gyrostabilized gun that could maintain aim while the tank traversed any terrain at combat speed. This technological edge, hidden in plain sight, would reshape armored warfare across 2 continents. The German armor doctrine that dominated the early years of World War II rested on a fundamental principle: tanks must stop to shoot accurately. This wasn't doctrine born from preference but from mechanical reality. Every tank in the Wehrmacht arsenal, from the Panzer III to the mighty Tiger, required a stationary firing platform for effective gunnery. General Heinz Guderian's tank manual, revised in July 1941 after 2 years of European conquest, explicitly stated, accurate fire requires complete stabilization of the firing platform. Commanders will halt their vehicles, acquire targets, engage, then resume movement. This stop-shoot-move cycle had served Germany well through Poland, France, and the early Russian campaigns. The physics seemed irrefutable. A tank traveling across uneven terrain experienced constant vertical and horizontal motion. The gun, mounted in a turret that itself moved with the hull, would bounce and sway with every irregularity in the ground. German engineers had calculated that even minor hull movement created angular displacement measured in degrees at the gun tube's muzzle, translating to meters of deviation at combat ranges. At the Aberdeen Proving Ground in Maryland, American engineers had reached a different conclusion. Beginning in 1939, a team led by Colonel Ernest Westervelt from the Army Ordnance Department had been working on a problem that most military establishments considered unsolvable: how to enable accurate fire from a moving tank. The Westinghouse Electric Corporation received a contract in March 1940 to develop what they called the Westinghouse Gyrostabilizer. The principle was revolutionary: use a gyroscope spinning at thousands of revolutions per minute to sense gun movement in the vertical plane, then employ hydraulic actuators to automatically compensate for that movement faster than any human gunner could react. By January 1941, prototype systems were being tested at Fort Knox, Kentucky. Initial trials demonstrated something remarkable: a Sherman equipped with the gyrostabilizer could maintain gun alignment within 2 degrees of vertical while traveling at 15 miles per hour across terrain that would normally induce 6 to 8 degrees of oscillation. The technical specifications, classified as secret under Army regulations, detailed a complex electromechanical system. The gyroscope assembly, manufactured to tolerances of 1/1000th of an inch, spun at 12,000 revolutions per minute. It sensed vertical displacement of the gun tube and sent electrical signals to hydraulic servos at a rate of 30 corrections per second. The system could compensate for vertical movement from 1/4 degree to 12 degrees, covering every realistic combat scenario. Testing protocols at Aberdeen proved the system's effectiveness. Traditional gunnery doctrine called for tanks to halt at ranges of 800 to 1,200 yards, acquire the target, and fire. With the gyrostabilizer, Shermans could engage targets at 1,000 yards while moving at 12 miles per hour with hit probabilities of 60 to 70%, comparable to stationary firing from earlier generation tanks. The German intelligence apparatus, despite its extensive network of agents and technical specialists, completely failed to detect this development. Abwehr reports from 1941 and early 1942 made no mention of American gun stabilization research. When the first Shermans arrived in North Africa in late 1942, German tank crews had no idea they were facing an opponent that could shoot while moving. November 8, 1942. The Allied invasion of North Africa, codenamed Operation Torch, brought American armored forces into direct combat with Axis troops for the first time. The 1st Armored Division landed near Oran, Algeria, while the 2nd Armored Division supported operations around Casablanca, Morocco. Hidden within these formations were 247 M4 Sherman tanks, each equipped with a gyrostabilizer system that would prove to be one of the war's best-kept secrets. Lieutenant Colonel Paul Robinette, commanding Combat Command B of the 1st Armored Division, had received specific instructions regarding the stabilizer system during pre-invasion briefings at Fort Benning. According to division records declassified in 1973, tankers were ordered to exploit the stabilization advantage without revealing its existence through communication or documentation that might fall into enemy hands. The first significant engagement occurred on November 10 near the coastal village of Sidi Farak, 15 kilometers west of Algiers. Elements of the German 334th Infantry Division, reinforced by a company of Panzer IIIs from the 190th Panzer Battalion, had established defensive positions along the coastal road. Hauptmann Rudolf Steiner, commanding the Panzer Company, deployed his tanks in hull-down positions with excellent fields of fire across 1,200 meters of open ground. American tactics, documented in after-action reports filed by Major Hamilton Howes of the 1st Armored Regiment, departed dramatically from expected doctrine. Rather than advancing to cover and exchanging fire from stationary positions, Sherman platoons moved continuously while engaging German positions. Steiner's report, captured when his unit surrendered 3 weeks later, expressed complete bewilderment at American tactics. The enemy tanks advanced at speed which should have made accurate fire impossible, Steiner wrote. Our doctrine assumes stationary firing platforms at these ranges. We halted, acquired targets, and fired according to training. The Americans continued moving while returning fire with inexplicable accuracy. 3 of my tanks were knocked out before we could properly engage. The gyrostabilizer's tactical advantage became apparent in multiple engagements throughout November and December 1942. German tanks, following their doctrine, would stop to shoot. This created a critical window, typically 3 to 5 seconds, where they were stationary targets. American Shermans, maintaining movement while firing, never presented that static target profile. Technical reports from the Armored Force Board, analyzing Operation Torch combat data, documented that Shermans equipped with stabilizers achieved first-round hit rates of 52% while moving at speeds between 8 and 15 miles per hour. German tanks firing from stationary positions achieved hit rates of 71%, but only after completing their stop-shoot sequence, which required an average of 4.7 seconds from movement cessation to shot release. The mathematics of engagement favored continuous movement. A Sherman traveling at 12 miles per hour covered approximately 17.6 feet per second. During the German stop-shoot sequence, American tanks moved 83 feet, complicating German range estimation and target tracking. Meanwhile, the stabilized Sherman could engage throughout its movement, maintaining offensive pressure without defensive vulnerability. By December 1942, German field reports from North Africa began noting unusual American firing techniques without understanding the technological basis. General Lieutenant Walther Nering, commanding the XC Corps in Tunisia, reported to Berlin that American tank tactics emphasize continuous movement with apparently effective fire control, contrary to accepted armored doctrine. The German military intelligence apparatus, considered among the world's most sophisticated, faced a puzzle they couldn't solve through conventional means. Throughout late 1942 and early 1943, reports from North Africa consistently described American tanks achieving accurate fire while moving, yet no captured equipment revealed how this was accomplished. The Abwehr, Germany's military intelligence service, tasked Abteilung 3C, Technical Intelligence, with investigating American tank capabilities in January 1943. Oberst Heinrich Baumann, heading the inquiry, assembled a team of armored warfare specialists at the Intelligence Evaluation Center in Zossen, outside Berlin. Their analysis, preserved in captured German documents now held at the National Archives, reveals the systematic failure to understand American technological innovation. German intelligence operated from flawed assumptions. Their technical experts believed that gun stabilization, while theoretically possible, required technology too complex and expensive for battlefield deployment. A February 1943 WWII assessment stated, gyroscopic stabilization would require precision manufacturing beyond current American industrial capabilities. More likely explanation, superior crew training or modified firing doctrine. This assessment reflected genuine German expertise in theoretical engineering combined with catastrophic underestimation of American manufacturing capacity. German gyroscope technology existed primarily in laboratory settings and specialized aircraft instruments. The concept of mass-producing 12,000 revolutions per minute gyroscopes with associated hydraulic systems for installation in tanks seemed economically and technically implausible to analysts who didn't understand American industrial scale. First physical examination of a captured Sherman occurred in March 1943 near Kasserine Pass, Tunisia. Panzer Regiment 8 overran an American position, capturing 3 damaged M4 tanks. German technical teams from Waffenprüfung 6, the ordnance testing office responsible for armored vehicle development, examined the vehicles at a field workshop near Tunis. The report, filed on March 28, 1943, and later captured by British forces, documented the discovery of the Westinghouse stabilizer system. However, German engineers fundamentally misunderstood its function. The report described a gyroscopic mechanism apparently intended for gun-laying assistance but concluded it was likely an experimental installation not present in standard production vehicles. This catastrophic intelligence failure stemmed from cognitive bias. German engineers couldn't believe Americans would install such sophisticated equipment as standard production items. Their own industrial experience suggested that complex electromechanical systems belonged in specialized vehicles, not mass-produced tanks. They assumed they had captured experimental or command variants, not representative production models. General Oberst Heinz Guderian, Inspector General of Armored Troops, received briefings on American tank capabilities in April 1943. His response, documented in Wehrmacht staff meeting minutes, dismissed the stabilization reports. If the Americans possessed such technology, they would have used it decisively. Our troops report American tank performance as adequate but not exceptional. Superior German gunnery and armor protection remain decisive advantages. This assessment, while fatally wrong about stabilization, reflected genuine German advantages in other areas. Tiger and Panther tanks possessed superior armor and more powerful guns than Shermans. German tanker training emphasized precision gunnery from stationary positions. These real advantages created confirmation bias, allowing German leadership to dismiss evidence that contradicted their technical superiority assumptions. By summer 1943, the pattern was clear in combat statistics that German intelligence failed to interpret correctly. American tank units consistently achieved higher first-round hit rates during mobile engagements, while German units excelled in prepared defensive positions. The data pointed directly to stabilization technology, yet German analysis attributed the pattern to terrain advantages or tactical circumstances. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. June 6, 1944. The invasion of Normandy brought American armor onto European soil in overwhelming numbers. The 2nd and 3rd Armored Divisions, along with separate tank battalions supporting infantry divisions, landed with 1,347 M4 Sherman tanks. Every single vehicle carried the Westinghouse stabilization system, now in its Mark II configuration with improved hydraulic response and enhanced gyroscope reliability. The Norman bocage, ancient farmland divided by thick earth and hedgerows topped with dense vegetation, created terrain perfectly suited to exploit the stabilizer's advantages. German defensive doctrine, developed by General Feldmarschall Erwin Rommel during his inspection tour of Atlantic Wall defenses, emphasized prepared positions with interlocking fields of fire. Panzer and anti-tank units would occupy concealed positions, waiting for Allied armor to advance into predetermined kill zones. Combat in the bocage shattered these assumptions. The confined lanes between hedgerows, typically 100 to 300 meters long, created engagement scenarios where American tanks encountered German positions at close range with minimal warning. Traditional doctrine required immediate halt and return fire. The stabilizer eliminated that requirement. Lieutenant Colonel Abrams of the 37th Tank Battalion, operating near St. Lo in July 1944, developed tactics specifically exploiting stabilization technology. Battalion records, preserved at the Armored School Library, documented what Abrams termed continuous assault fire. Sherman platoons would advance through bocage lanes without stopping, firing at suspected positions as they moved, maintaining momentum that prevented German defenders from effectively engaging. Hauptmann Joseph Hartmann, commanding a company of Panther tanks from Panzer Lehr Division, encountered these tactics on July 15 near Pont-Hébert. His after-action report, captured when his unit was encircled 3 days later, provides a German perspective on fighting stabilized Shermans in close terrain. American tactics make no sense according to armor doctrine, Hartmann wrote. They advance continuously, firing while moving through terrain that should force them to halt. Our Panthers have superior armor and guns, but we must stop to engage accurately. In the 3 to 5 seconds required to halt, acquire target, and fire, American tanks have already fired twice while advancing. Their rounds lack penetrating power against frontal armor, but they achieve hits on our tracks, vision blocks, and gun mantlets before we can respond. The stabilizer's effectiveness in bocage fighting came from psychological as much as technical advantages. German tank commanders, trained to acquire targets carefully and fire from stable platforms, faced opponents who seemed to shoot recklessly while advancing. This created the impression of aggressive American tankers willing to close range rapidly, though the reality was technological rather than temperamental. Statistical analysis by the Operational Research Section of 1st Army, compiled in August 1944, revealed the stabilizer's impact. In bocage engagements at ranges under 400 meters, American tank units achieved 47% first-round hit rates while moving. German tanks, firing from prepared positions, achieved 68% accuracy, but required an average of 5.3 seconds from target acquisition to shot, during which American tanks advanced 77 feet and fired an average of 1.8 rounds. The mathematics favored American tactics. While German guns could penetrate Sherman armor reliably, they had to hit first. The stabilizer ensured that American tanks shot first in close-quarters engagements, and in armored combat, first-shot advantage often proved decisive regardless of armor protection. By late July 1944, German tank losses in Normandy had reached crisis levels. Panzer Lehr Division, which landed with 183 tanks, reported only 47 operational vehicles by July 25. While Allied air power contributed significantly to these losses, ground combat against American armor accounted for substantial attrition that German planners had not anticipated. September 1944. As American armored divisions pursued retreating German forces across France and into the Low Countries, the Wehrmacht finally began serious efforts to develop their own gun stabilization technology. The impetus came from General Oberst Guderian himself, who had belatedly recognized that American fire-on-the-move capability represented a genuine technological advantage rather than superior crew training. The Heereswaffenamt, Army Weapons Office, issued specifications in September 1944 for a stabilization system to be retrofitted to Panther and Tiger II tanks. The project, designated Term Stabilisator Gerät 42, was assigned to Zeiss Optical Works and Bosch Electrical Systems. Engineering documents captured by American forces in 1945 reveal the technical challenges German designers faced. German engineers, approaching the problem from first principles, designed a system more sophisticated than the American stabilizer but impossibly complex for wartime production. The Zeiss-Bosch design incorporated two-axis stabilization, both vertical and horizontal, compared to the single-axis American system. It required precision optical components, 17 electric motors, and hydraulic systems operating at pressures that exceeded available German pump technology. First prototype installation occurred in December 1944 on a Panther OSF G at the Kummersdorf testing facility. Initial trials demonstrated theoretical superiority over American systems when it worked. The complexity created reliability problems. The system required 15 minutes of warm-up time before operational use. Optical components fogged in cold weather. Electrical systems suffered cascading failures when individual motors malfunctioned. By January 1945, with Soviet forces approaching from the east and Allied armies massing in the west, German industrial capacity could not support production of such complex systems. The program was officially terminated in February 1945, with only 7 prototypes completed. None saw combat service. Meanwhile, American armored operations in the fall of 1944 demonstrated the stabilizer's value in pursuit warfare. The 4th Armored Division's race across France, covering 600 miles in 30 days during August and September, relied heavily on the ability to engage targets while maintaining rapid advance rates. Colonel Bruce Clark, commanding Combat Command A of the 4th Armored Division, described stabilizer tactics in his October 1944 operational report. Our doctrine emphasizes continuous movement. Tank platoons advance in traveling formation, prepared to engage targets immediately upon contact without halting. The stabilizer allows offensive fire during movement, maintaining initiative and preventing enemy forces from establishing prepared defensive positions. German forces attempting to delay American advances found traditional defensive tactics increasingly ineffective. Positions that should have required coordinated infantry tank assaults to reduce were instead engaged by moving American tanks that fired accurately while advancing. The psychological impact matched the tactical effect. German troops reported feeling unable to slow American armor regardless of defensive preparation. The distinction between American and German approaches to armored warfare became starkest during the Battle of the Bulge in December 1944. German offensive operations, launched through the Ardennes, relied on traditional armor doctrine, rapid movement to contact, then stationary firing. American defensive operations utilized stabilized fire to engage German armor during its approach, before Panthers and Tigers could deploy in favorable positions. At Bastogne, tank destroyer and tank units defending the perimeter engaged German armor at ranges from 800 to 1,200 meters while German tanks maneuvered for firing positions. The 10th Armored Division, holding the southern shoulder of the German salient, reported engaging Panther tanks that were moving to hold down positions, destroying them before they could complete deployment and return accurate fire. The strategic advantage of American gun stabilization extended far beyond individual tank engagements. The true revelation lay in America's ability to mass-produce complex electromechanical systems at a scale German industry could not approach even in peacetime, much less under wartime conditions. The Westinghouse manufacturing facility in Sharon, Pennsylvania, dedicated an entire production wing to gyrostabilizer manufacture beginning in 1941. By 1943, the plant employed 2,847 workers operating in 3 shifts, producing an average of 47 complete stabilizer units per day. Total production through the end of the war reached approximately 21,000 units, enough to equip every Sherman tank produced from mid-1942 onward plus reserves for replacement and repair. German intelligence analysts, examining captured American equipment in 1944, expressed disbelief at the industrial implications. A technical report from Waffenprüfung 6, dated November 1944, noted, the Westinghouse stabilizer requires precision machining to tolerances of 0.001 inches, specialized electrical components, and complex assembly procedures. That the Americans install this equipment as standard production items in medium tanks demonstrates manufacturing capacity beyond our previous assessments. The cost differential between American and German approaches to armored warfare became apparent in comparative analysis. Each Westinghouse stabilizer cost approximately $2,100 to manufacture in 1943 dollars. The complete Sherman tank cost $44,556. Adding stabilization increased unit cost by less than 5% while providing significant tactical advantages. German attempts to develop comparable systems in 1944 to 1945 revealed prohibitive costs. The Zeiss-Bosch prototype stabilizer, designed for the Panther, carried an estimated manufacturing cost of 47,000 Reichsmarks, approximately $18,800 at 1944 exchange rates, nearly equal to the cost of the Panther's main gun. German planners concluded that stabilizer installation would increase Panther production costs by 22% while reducing overall production rates due to increased manufacturing complexity. The industrial philosophy differed fundamentally between American and German armored forces. American doctrine emphasized standardization, mass production, and technological improvements that could be manufactured at scale. German doctrine pursued technical superiority through specialized designs, accepting higher costs and lower production volumes in exchange for battlefield performance advantages. Sherman tanks, equipped with stabilizers, sacrificed armor protection and gun power compared to German Panthers and Tigers. But American industry produced 49,234 Sherman tanks during the war, compared to 6,000 Panthers and 1,347 Tigers. The stabilizer allowed adequate tanks to be employed effectively in overwhelming numbers, negating the individual superiority of German vehicles. Lieutenant General Jacob Devers, commanding 6th Army Group in late 1944, articulated this philosophy in a report to Army Chief of Staff George Marshall. Our armor may be individually inferior to the best German tanks, but our stabilization systems allow us to employ our tanks more aggressively and in greater numbers. Superior technology deployed at scale defeats superior weapons deployed in limited quantities. The stabilizer program demonstrated American industrial warfare doctrine at its finest: identify a battlefield problem, develop a technological solution, and manufacture it in quantities that overwhelm enemy responses. German forces could build better individual tanks, but they could not match American capacity to deploy adequate technology in decisive quantities. By early 1945, German tank commanders faced opponents who could fire accurately while moving, who appeared in overwhelming numbers, and whose industrial base could replace losses faster than German forces could inflict them. The stabilizer, combined with American production capacity, created an asymmetric advantage that no amount of German technical sophistication could overcome. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The stabilizer's impact extended beyond mechanical advantage into the psychological realm of armored combat. German tank commanders, trained in doctrine emphasizing careful target acquisition and deliberate fire from stationary positions, found themselves facing opponents who seemed to violate fundamental principles of gunnery yet achieved consistent results. Oberleutnant Werner Wolf, commanding a platoon of Panzer IVs in the 116th Panzer Division, survived the war and provided testimony to American historical investigators in 1946. His account, preserved in the United States Army's Foreign Military Studies program, reveals the psychological stress of fighting stabilized American tanks. We knew our tanks were inferior in armor to the Tigers and Panthers, but our training was excellent, Wolf stated. We practiced gunnery until we could achieve first-round hits at 1,200 meters from stationary positions. But against the Americans, our training meant nothing. They would advance toward our positions, firing continuously. We would halt, acquire our target, prepare to fire, and in those seconds, they had already hit us twice. Some of my men began to panic, firing wildly while moving, abandoning their training. This made them even less effective. The stabilizer created tactical confusion that German commanders struggled to counter. Traditional anti-tank doctrine relied on concealment, surprise, and first-shot kills from prepared positions. American tanks, able to fire effectively while advancing, reduced the value of concealment because they could engage suspected positions without exposing themselves through stationary deployment. Major Rudolf von Gersdorf, intelligence officer for the 7th Army defending Alsace in late 1944, attempted to develop tactical countermeasures. His December 1944 directive to subordinate units, captured by the American Third Army, instructed tank commanders to engage American armor at maximum range before they can close to distances where their movement-based tactics become effective. This guidance proved difficult to implement. The 75mm gun on the Sherman had effective range comparable to German tank guns. By the time German commanders identified American tanks at maximum engagement range, Shermans were already within their effective firing envelope and advancing while shooting. German tanks that remained stationary to achieve maximum gunnery accuracy became vulnerable to American tanks that sacrificed some accuracy for continuous offensive fire. American tankers, meanwhile, developed confidence in their ability to engage German armor despite individual vehicle inferiority. Staff Sergeant Raymond Guthrie, tank commander in the 3rd Armored Division, described stabilizer tactics in his 1945 debriefing. "We knew their tanks had better armor and bigger guns. But we also knew we could shoot while moving and they couldn't. So our tactic was simple: keep moving, keep shooting. Even if our first shot didn't penetrate, it made them button up, disrupted their aim. By our 3rd or 4th shot, we'd hit something critical: tracks, gun mantlet, vision ports. Then they were disabled and we could maneuver for a kill shot." The psychological advantage worked both ways. American tank crews felt less vulnerable because constant movement made them harder targets. German crews felt increasingly vulnerable because their tactical doctrine, halt, shoot, move, created windows of extreme vulnerability that American stabilized fire exploited ruthlessly. By early 1945, captured German documents revealed declining morale among tank crews. A February 1945 report from Panzer Regiment 24 noted, "Crew confidence has deteriorated significantly. Men express fatalistic attitudes about engaging American armor, believing our tactical doctrine places us at disadvantage regardless of our vehicle's technical superiority." This psychological degradation mattered as much as physical destruction of German tanks. Units that believed themselves disadvantaged fought less aggressively, withdrew more readily, and surrendered more easily. The stabilizer, beyond its technical function, had become a weapon that attacked German tankers' confidence in their training, their doctrine, and their equipment. In armored warfare, where crew performance often determined combat outcomes, this psychological edge proved as valuable as any mechanical advantage. The American Armored Force Board, analyzing combat reports from the European theater in March 1945, concluded, "The gyrostabilizer has provided our tank crews with tactical flexibility and psychological confidence that outweighs the Sherman's deficiencies in armor and gun power. Enemy forces recognize our ability to fire effectively while moving and have not developed successful countermeasures." March 1945. As Allied armies crossed the Rhine and drove deep into Germany, the stabilizer's role in armored warfare reached its culmination. The 2nd and 3rd Armored Divisions, spearheading 1st Army's advance, covered distances that would have been impossible under traditional tank warfare doctrine requiring frequent halts for engagement. The pursuit across central Germany demonstrated stabilization technology's strategic implications. Tank formations could maintain advance rates of 30 to 50 miles per day while engaging German resistance without stopping. This operational tempo prevented German forces from establishing coherent defensive lines, forcing them into a series of hasty withdrawals that accelerated the Wehrmacht's collapse. General Courtney Hodges, commanding 1st Army, noted in his April 1945 report, "Our armored divisions have achieved rates of advance unprecedented in military history." The ability to engage enemy forces while maintaining movement has transformed armored operations from sequential engagements, move, stop, fight, move again, into continuous offensive action. The enemy cannot prepare positions because our tanks arrive before preparations are complete, engaging immediately without tactical pause. German defenders found themselves in an impossible tactical situation. Traditional defense required time to prepare positions, mine approaches, and coordinate fields of fire. American armor, advancing rapidly and firing effectively without stopping, denied German forces the time required for preparation. Positions that should have taken hours or days to reduce fell in minutes to tanks that never stopped moving. The statistical evidence, compiled by the European Theater Operational Research Section in May 1945, revealed the stabilizer's cumulative impact. American tank units achieved average advance rates 40% higher than comparable British or Soviet armored formations. Loss rates per mile advanced were 23% lower than British tank units using Shermans without stabilizers in Italy. These differences, compounded across hundreds of engagements and thousands of miles, represented decisive operational advantages. Comparison with other Allied tank forces highlighted the stabilizer's unique value. British and Commonwealth forces used Sherman tanks throughout the war, but most British Shermans had stabilizers removed or deactivated. British tank doctrine, influenced by North African experience, emphasized deliberate advances with prepared fire positions. British tank commanders considered the stabilizer unnecessary for their tactical approach and maintenance-intensive in field conditions. Soviet armored forces, receiving American equipment through Lend-Lease, also generally removed stabilizers from Sherman tanks. Soviet doctrine emphasized massed tank assaults at close range where stabilization offered minimal advantage over their preferred tactics of overwhelming enemy positions through numerical superiority and aggressive close-quarters combat. Only American forces fully exploited stabilization technology because only American doctrine fully integrated fire on the move into tactical employment. The technology required doctrinal adaptation to achieve maximum effectiveness, crews trained to engage while moving, tactics designed around continuous advance, maintenance procedures to keep complex systems operational. The post-war assessment by the United States Armored Force Board, published in December 1945, concluded, the gyrostabilizer represented one of the most significant technical innovations in armored warfare during World War II. While individual German tanks possessed superior armor and armament, American tanks equipped with stabilizers achieved tactical advantages through fire-on-the-move capability that German forces never effectively countered. German post-war analysis, conducted by former Wehrmacht officers for the United States Army Historical Division, acknowledged the stabilizer's impact. General Major Friedrich von Mellenthin, Chief of Staff for several Panzer armies, wrote in his 1947 assessment, American tank gunnery stabilization provided consistent tactical advantage in mobile engagements. German tank forces, bound by doctrine requiring stationary firing, could not exploit our superior armor and gun power before American tanks achieved disabling hits. This technical advantage, combined with overwhelming American numerical superiority, made defending against American armor increasingly futile by 1945. The stabilizer's legacy extended beyond World War II. Every main battle tank developed after 1945 incorporated gun stabilization as standard equipment. Modern tanks use sophisticated computer-controlled stabilization systems in multiple axes, but the fundamental principle, maintaining gun alignment independent of hull movement, traces directly to the Westinghouse gyrostabilizer developed in 1940. The technological edge that German troops never fully understood had helped win the war. The story of the Sherman tank's stabilized gun system represents one of World War II's most significant yet least publicized technological advantages. While the atomic bomb, radar, and code-breaking captured public imagination, the humble gyrostabilizer fundamentally altered the tactical balance of armored warfare in ways that directly affected battlefield outcomes across 2 years of combat. The numbers tell part of the story. Between November 1942 and May 1945, American armored forces equipped with stabilized Shermans participated in every major campaign in the European and Mediterranean theaters. They fought in North Africa, Sicily, Italy, France, the Low Countries, and Germany itself. Across these campaigns, American tank units consistently achieved tactical results that exceeded what the Sherman's specifications suggested possible. German military analysts, denied access to American technical manuals and unable to examine intact stabilizer systems until late in the war, never developed effective countermeasures. They knew American tanks could shoot while moving with inexplicable accuracy, but their solutions, longer-range engagement, heavier armor, more powerful guns, addressed symptoms rather than the underlying tactical problem. The stabilizer's true genius lay not in revolutionary technology but in practical engineering applied at industrial scale. The Westinghouse gyrostabilizer used principles known to German engineers, but American industry manufactured these systems in quantities German planners considered impossible. This exemplified American warfare doctrine: adequate technology deployed in overwhelming quantities defeats superior technology deployed in limited numbers. Captain James Burt, who received the Medal of Honor for his actions commanding a Sherman tank company in Germany in October 1944, reflected on the stabilizer's importance in his 1946 testimony to the Armored Force Board. "We all knew our tanks were outgunned and out-armored by German Panthers and Tigers. But we also knew we could hit them while moving and they had to stop to hit us. That knowledge, that technological edge, gave us confidence to close with superior enemy tanks and win through aggressive tactics. Without the stabilizer, I don't believe we could have been so aggressive, and without that aggressiveness, our casualty rates would have been catastrophically higher." The human cost calculations support Burt's assessment. Operational research conducted in 1945 estimated that without stabilizers, American tank casualties in the European theater would have increased by 35 to 45% based on comparative analysis with British tank operations using unstabilized Shermans. This translates to thousands of additional casualties avoided through a technology that cost less than 5% of each tank's production price. Perhaps the stabilizer's most profound impact was psychological rather than mechanical. American tank crews fought with confidence that their training and technology could overcome German advantages in armor and firepower. German tank crews, despite superior vehicles, increasingly fought with the knowledge that American tanks could engage them effectively under conditions where German doctrine taught that accurate fire was impossible. The last documented combat use of Westinghouse stabilizers in World War II occurred on May 7, 1945. When elements of the 2nd Armored Division engaged retreating German forces near Wismar on the Baltic coast. Even in the war's final hours, American tanks advanced while firing, maintaining pressure on German units attempting to reach Allied lines ahead of Soviet forces. The gyrostabilizer remained classified technology until 1947, when the Army declassified technical specifications and combat employment doctrines. By then, every major military power had begun developing stabilization systems for their own tanks, but American forces had enjoyed a 2-year head start that contributed materially to Allied victory. Today, the principle pioneered by the Westinghouse engineers in 1940 remains fundamental to armored warfare. Modern main battle tanks use computer-controlled stabilization systems that maintain gun alignment through 3 axes of movement, but the basic concept, allowing accurate fire from moving platforms, traces directly to those 8 stabilized Shermans that surprised German defenders in Morocco in November 1942. The German troops who faced stabilized Shermans never fully understood the technological edge that put them at such disadvantage. They died or surrendered without knowing that a spinning gyroscope and hydraulic actuators, hidden inside American tank turrets, had fundamentally altered the calculus of armored combat. That hidden edge, manufactured by the thousands in Pennsylvania and installed in tanks that seemed adequate rather than exceptional, helped win the war in Europe. It proved that in modern industrial warfare, the side that effectively combines adequate technology with overwhelming production capacity defeats the side that pursues technological perfection in limited quantities. The stabilizer's legacy endures in every modern tank that fires accurately while moving, a capability that German troops in 1942 believed impossible, that German engineers in 1944 couldn't replicate at scale, and that American industry delivered as standard equipment in tens of thousands of tanks. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.